today we will be looking at relational data. Um, if we want to put it in context, you just say we are looking at things you can look at as databases, not just tables. I know that if you've done any project at all in data science, or if you looked at data sets in mainly CSV formats, those are just tables, individual tables. And you can look at the individual tables as characterized by instances and attributes. Now, what I mean by that is simple. If you can look at the screen right now, you can see a table made up of four attributes: the ID, the last name, first name, and rows. Are made up of 6 instances. An instance basically gives you a description of a particular entry. Now, what that means is this: for example, this row across from 1 to instructor is an instance. Basically, it gives you a description of an individual. In this case, the individual's ID is 1, his last name attribute is Cutler, Coulter, and his first name attribute is Zico, and his row attribute is instructor. So you can see that for each instance, every instance has its own value for attribute, except in the case whereby that does not. But for this particular table, every instance has a first name, a last name, and a row, and also obviously an ID. So you look at the rows as instances, or what you could call a tuple. Then you look at each column as an attribute. Basically, within each column is something that is a variable, a specific variable that each particular record takes. For example, the record with the ID 1 has a variable name, last name of Coulter, while the row is instructor. So that's just basically a table. And I know you've seen Excel worksheets, you've seen CSV files, and some of us could easily have worked with databases. Let's continue now. But when we look at databases, we want to look at it within the context of more than just one table. So in this case, what we've been able to do is we've divided this table, which has all this information, into 2 tables. Now you might wonder why. Now, for several reasons, it makes sense to divide. For example, if you look at this table presently on your screen, the row attribute is not unique in that you have multiple values of TAs, different TAs and different students. But considering the fact that these rows are not things that people are going to impute themselves. For example, basically there are 3 categories here. People can have different name, first name, and different last name, but within the context of this particular instance that we're working with, we either have an instructor, a TA, the instructor, a TA, or a student. So somebody has to fall in within those 3 categories. So that being said, it would be more ideal to instead make this row attribute into a table of unique values, and then have some kind of a way whereby you can connect this other part of the table to the new table, which is what has happened here. So what has basically happened is that we've created a unique table for a row that has just the instructor, the TA, and the student as the unique values, and an ID of 1, 2, 3. So in the persons table now, all we would have for each individual is a row ID that corresponds to their particular roles. So in this case, you see that Colta Zico has a row ID of 1, which corresponds to instructor, and the next three individuals have a row ID of 2, which corresponds to TA, and the last three, which corresponds to students. These are basic things that we know. Now we come back to the concept that are actually quite important when we are dealing with relational data, which is the concept of keys. Now, if you a primary key, like it's written here, is basically a unique ID for every row in a table. So every table will have, all tables will have one primary key, not more than one. So in this case, for our person's table, we have a primary key of ID, which is 1, 2, 3, 4, 5, 6. Now, in this case, now you could easily say that this ID corresponds to every particular person. Every person has an ID. Now, when you come to the row table, you find that every row has an ID. So basically, every person can be identified by a unique ID, and every row can be identified by a unique ID. Hence, those IDs are the primary keys. So if you wanted to find a role, just find the ID and you'll be able to find that particular row. Now, there's a second characteristics that a relational data also have, called a foreign key. The idea is this: the foreign key within a table, like this person's table, is actually a primary key in another table, such that you use the foreign key as a basis to identify that particular attribute within the table where that that foreign key is a primary key. In this case, the row ID is a foreign key, which you could easily use to correspond to the primary key within the row table. So the row ID 1 corresponds, you use it to connect to the row table ID 1, which is instructor. So these are just the basic concepts that you need to understand, because at the end of the day, the idea is of having multiple tables. There's no point having multiple tables that you do not have a way of connecting to them. It means that then those tables are islands on their own without there's no relationship between them. But for there to be a relationship between them, the concepts that are quite important are the roles of the primary key and the foreign key, which serve as a basis for which we can connect tables together. So like it said here, for example, if you delete a primary key from the row, for example, from the, let's say this particular instance, we don't have TAs. Maybe this was for this year's class, what we are saying here. If in next year's class, the instructor only exists without TAs, what would happen is that you would delete this ID2 from the row table. But then for it to, by doing that, you also have to delete all the instances of where row ID 2 is used within the person's table, because obviously if you don't have TAs, it means that these individuals will not exist in this person's table. So they go in hand. So if you don't have it, but obviously you can have a situation whereby there are no TAs within the foreign key table, maybe because they presently do not exist, but that row exists. So the row could easily be filled up much later. But the other way around is not possible. Now, let's go ahead. Now, when we look at another thing that's particularly important is the role of indexes. The idea being to use a particular attribute as a way of filtering your table. For example, if you were to use the last name as an index, what will happen is this: if you were looking for a name, for example, Gates as a last name, you could easily filter your table based on that index, maybe alphabetically, and it makes it easier for you to know where exactly you can find that particular name, because obviously Gates starts with G. So you know that if your table is starting from an A, you can easily scroll and find what you're looking for. But if that is not the case, if you didn't have some kind of way of sorting it, it will become quite difficult, especially in the cases whereby you have very, very large tables to filter. Now, um, so that's really basically what the roles that indexes play within this context. Now, one now I would like to ask, considering what we've done so far, does anyone have a question? I would like us, if you have any part, based on as I go along, if you have a question or a contribution, I'd like you to just raise your hand so that it won't just be me speaking and making it look like I'm talking to myself. If you have a concern or a question and you need some clarification, please indicate by raising your hand, and I will gladly allow you to do that. Now, let's go into entity relationships. Now, in the concept of entity relationship basically looks at how are tables related. Let's look at if you are looking at two tables now, we want to find out how are these two tables related. Is it a one-to-one relationship? Is it a 1 to 0 / 1 relationship? Or is it a one-to-many relationship? Or a many-to-one relationship? Then obviously you talk about a many-to-many relationship. Now, these particular concepts are quite important because when you're dealing with let's look at sales, for example. Now, let's say a supermarket has a database. Now, every day purchases are made, there are transactions. But for every transaction, let's assume that the supermarket has the name of its customers, the details of its customers, the details of the product that it sells, the details of the cashiers, its staff members, salespeople. Obviously, what you would have is a table that contains every transaction. Okay, on this particular day, this was bought in this quantity, and this and that, this kind of product, and so on and so forth. But it will also have a table of all its unique products with the product pricing and all other granular information about the individual products. Then another table will obviously also exist for the customers, having a customer ID and the customer name, first name, full name, maybe email address, do they have kids, and all granular information about the customer. Then you also have that for maybe the salespeople. Now, what then happens is that on the transaction table, you would have for each transaction that is done, for example, someone bought milk. Now, you possibly have the unique ID for that particular milk brand in the transaction detail. In what quantity was it bought? By what cost? Which customer did the buying? Now, you would have that information in the transaction table. So such that if you wanted to find out, you would connect this transaction table to the customer table and the product table to be able to do your analysis. Now, in the case of dealing with, we would start with one of the most critical ones that happens a lot is the one-to-many relationship. You're actually going to have it a lot. For example, the example I gave about the transaction information, maybe sales information within a supermarket, what you have is that there will be a lot of transactions, multiple transactions. There will be multiple instances within a particular day. There will be multiple instances where you bought a particular brand, a brand of milk was bought within the transaction table. But there will be only a unique, that particular instant. Let's say, for example, peak milk. We sold peak milk every single day within this week. But within a within a product table, there's just peak milk. And then peak milk is described with the pricing and everything like that, and every other information you want to get on that. So let's look at the tables that are made available on the slide. In this case, we have a person table and we have a row table. You'll find out that the row instances are unique in that you have just instructors, TAs, and students. But within the persons table, you will see that the rows, you have 3 TAs, 2 students, and 1 instructor. So you could find that the relationship between this person table and this row table, it's a many persons in the persons table to 1 row in the rows table. So you could easily have 3 different people with 1 particular row, which is TA, and 2 different people with another particular row, which is student. So you have a many to 1 relationship. Now you go to the next kind of relationship where we talk about a one-to-one relationship. Now, this is a situation whereby you're looking at unique values across 2 tables. Now, you would notice that sometimes it's not a really common relationship. I personally haven't had to use one in my time as a data analyst because they are rare. I think there are other ways that the table could be constructed. For example, what could easily happen in this instance is that rather than have this Andrew ID, we would rather have a situation whereby the Andrew information is put within the person's table. Because at the end of the day, if they are going to be unique, it means that it doesn't really but there are instances where this might be necessary, but they are very, very rare. There are very, very few occasions where you come across this, whereby it's a one-to-one relationship. Like you can see, 1 role ID, the row ID corresponds to 1 Andrew ID. So every row has its own peculiar Andrew ID in this particular case. So that's the concept of a one-to-one relationship, but it's not really something you come across a lot. Now, the next one is something you call a 1-to-0/1 relationship. Now, let's try and see if we can. Now, it is possible for you to have a person. For example, you have a list of individuals and you have a list of grades. Multiple individuals, every individual ordinarily should have a grade. But think about a student who didn't write an exam. Obviously, he's supposed to have a grade, but he wouldn't have a grade because he didn't write the exam. So in that case, the relationship between that individual and the grade table will be a 1-to-0 but the relationship between other individuals who have grades will be 1-to-1 or 1-to-multiple, as the case may be. So that's the concept that this actually follows. Then you have a many-to-many relationship. The many-to-many relationship is another one which doesn't always, at least most times, tables are not structured like this. What you're basically having in this instance is this. Now think about it this way. There's a person and their homework and score, and then their homeworks. So what you have is a situation whereby multiple persons can have multiple homeworks, in that individual 5 and 6, let's say, let's call them by name, let's say Emeka and Fred, both have homework 1 and 2. Then also homework 1 and 2 exists for both Emeka and Fred. So in that instance, you have a situation whereby they both have the same score, the same they could both have the same characteristics. One individual can have multiple homeworks, and multiple homework could be allotted to a particular individual. And you could also have multiple individuals having multiple homeworks or falling within different thresholds. For example, now, let's look at it this way. If we had a score, for example, people got 60, 80, and 100, and this is different individual. Now, you'll find out that the same person could get fall within this particular mark for one homework and fall within another particular mark for another homework. So in this case, you're having a situation whereby you need to use 2 keys to be able to relate with each other. You have to use the person ID, and also you have to use the homework ID to connect these 2 tables together. In that, you would use the person ID to connect to the ID here, and then you would use the homework ID to connect to this name here, for you to be able to get, for that particular individual, for that particular homework, what is the person's score. That's what we are dealing with here. For each individual, for a particular, remember, each individual can have multiple homeworks. So, and there are multiple homeworks in the table, in the homework table. Okay, Jerry, you can unmute
Okay.
yourself and ask a question if you have one.
Okay. Actually, it's on the minute 1 to 0/1.
Okay, go ahead.
Yeah. So let's say you're on a table that has the person ID and all the stuff, and
Okay.
then one person has no grade, but you are
Yes.
trying to call. You don't know. There's no way you know on the first table that this person did not do the assignment, because that only reflects on the second table, right? So since it is 1 to 0, and then you try calling from table 1, how are you going to know, since that guy doesn't relate to anything on the second table?
What you
Am
get
I
is
clear?
you get a blank result.
Or it's not going to give me like this person does not exist on that table.
No, you
Kind
get,
of error.
it is not a it won't speak to you. What you are saying is, for this person, check this table, does he have a record? It's going to give you
Okay.
true or false. So
Okay.
if not that it will give you a result of true or false. Basically, when you make a query, the first thing that needs to be certified is, does this record exist or not? If
Yeah.
it exists, then depending on what you ask it to make available to you, it will give you that information. But if it doesn't exist, what will be returned to you is something blank, telling you that
Okay.
some way the record you are seeking does not exist within this table. That's what will happen.
Okay. All
All right.
Thank you.
You're welcome. All right. Does someone else have a question before we go on? Okay, for now, I don't think there's anyone asking any question. Maybe you should. Please, Ahmed,
Yeah,
are you asking a question? If not, please kindly mute yourself.
yeah. I want to ask a question.
Okay, please do.
I mean, the first one you talked about, it was one-to-many relationship.
Yes, please.
But before you left the slide, you mentioned many-to-one relationship. Was that the
Uh,
or it was a mistake?
there is one to Now you need to look at it this way.
Okay.
When you talk about relationships, it's both ways. You can call it a one to many or a many to one.
Okay.
You can swing it the other way around, because within the concept of the table, it depends on where you are starting from. So it could be one to many or many to one. It means the same thing.
All right.
Because what you have now is you have a person many to row one relationship, but you could also have a row one to many persons relationship, which is the same thing. It's just a case of semantics or the order in which you went about it. The
Okay.
important thing is for you to understand. The important thing is for you to understand what exactly is happening. Because what will happen is, if you were writing maybe an SQL query, you could say select all. You could select all, or you could say select um, last name, first name, and row, where row ID, where row ID is one, where row ID is one, join left join on row ID, person row ID equals to row ID. Basically, what that SQL query will give you is, it will give you a list of the last name, first name, and instruct the name from the row for which you described. In this case, we are saying, show me all the instances plus the actual row of anyone that has a row ID of one. So what you would have in that instance is Kotler, Zico, and instructor within a table. That's what will be returned to you. So that's how you use those things. So whether it's one to many, it's just for you to understand how your table, because um, if you have worked with Excel, you might not necessarily, except you worked with things like Power Query. If you work with Power Query in Excel, for example, you would have to go to what we call a data model, whereby you connect tables to tables. Now, in connecting tables to tables, it will be important for you to understand cardinality. And that's what we are talking about here. The cardinality is many to one, in that one table has a unique value, while the other one doesn't have unique values. In this case, our person's table obviously is not unique. You can have multiple people, different names, but you can't have, for example, in the Excel and Power BI community, they talk about what you call lookup tables and what you call I can't remember the other one, where lookup tables will always have unique value. For example, your product table, every company has a unique set of products. So within the concept of a table, you have all those products and their description. They are all unique. Like this case, you have just three unique rows,
Yeah.
but you can have a different variety of human beings. For example, in this person's table, you have unique individuals, but you can have so many different kinds of individuals. And you can see that the rows and several individuals can assume same rows. So that's just the concept. The idea is for you to understand how tables connect to each other, not whether it's many to, knowing that it's many to one, many to many. It helps you in when you're doing your analysis, not necessarily the nomenclature.
Thank you.
You're welcome. Now, okay, these are just this. Now, let's go to something quite interesting. Interestingly, one thing you will find is that in the data science community, depending on what area you want to play, there are different tools that are going to be quite critical. For example, if you were a data analyst, depending on what kind of company you're working with, um, right from a very long time ago, in most cases, you would usually use Excel and SQL. Now, lately, tools like Tableau, Power BI, and Python have become quite essential also. Now, what will happen is this. even what we're about to do now, even though we are going to be doing it within the concept, we are going to be doing it within Python, you will find out that the query we are writing is actually SQL, but we are writing it from Python. But we will still use SQL queries to write it, as you will see as we go along. So SQL is actually quite important, because when it comes to the world of relational databases, although um, in this day and age we have non-relational databases, but for this class we are going to be sticking strictly with relational databases, because if you work for a company, it is likely that most of their information is stored within a database. Most of their information will be stored within a database. So for you to be able to reach it, you will need to know a bit of SQL, especially if the information you want doesn't exist within one table. You have to be able to find a way of joining the tables to be able to extract the information you want. But you could do this within the Python environment using pandas. Um, Using pandas. So let's just go ahead. Just hold on, please. So I know that I want to expect that each and every one of us has worked with pandas, so I don't want to bore us. This is basically setting up a data frame within pandas. We would take care of all this when we start running the code. It's better to deal with things like this when we get to that point. Um, let's just continue. Uh, we'll go. Let me see. SQLite. Now let me see if there's any additional information. Okay, let's deal with joins. What I just went past now are basically things related to code, and it will be more ideal to work on them when we are dealing in a Jupyter notebook rather than the slides. Then we can deal with any other thing that comes up practically. So let's look at the concept of joins. Now, there are basically four types of join: inner, left, right, and outer. The right and the left are quite similar. Quite frankly, if you know the inner and the left and the outer, you'll be just fine. You don't need to even bother yourself, because all you need to do is, in using left and right, for example, if I did something and I did left join on two tables, if I wanted to do the right join of it, all I need to do is to flip, to use the table I used as the first one for doing the left join. If I wanted to do the right join, I'll use it as the second one. So if I was joining the person to row table using a left join, if I wanted to do a right join, I can still do a left join, but in this case, I will use the row table first and join it to the person's table. So let me just explain to you what they actually mean. Now, the easiest way of trying to understand what a join and an inner join means is just look at two. Many of us did. There's this topic in maths called, even way called sets. For example, you have two circles. The inner join is basically an intersection within the two circles. So if you draw two circles whereby the two circles um, intersect with each other, that everything within that intercept is what an inner join is. In this case, now let's look at these two tables. Now, if we were to do an inner join of these two tables, what you would find is We'll join these tables based on the ID column for the person's table and the person ID column for the grades table. So if we were to do an inner join, what we are basically saying is this: join this table such that for the ID of the person's table and the person ID in the grades table, only leave a table that joins where the IDs correspond in both cases. So what you would have here is that you would see that the ID in the person's table, you have 1, 2, 3, 4, 5, 6. But for the grades table, we only have 5 and 6. So what you would have is a situation whereby if you do an inner join for this table, you would just have the records for Gates, Williams. Those are the only records you are going to have. Please hold on. Give me 2 seconds. I need to attend to someone. All right, I'm back. Sorry about that. Someone was knocking at my door. I needed to take care of that. All right. So what I'm basically saying is, I think before I went off, I was talking about inner joins. So let's just practically look at what would happen in this case. Take note of the fact that in the person's table, the IDs, the ID. Uh, okay, let me see. Okay, Kingsley says, so inner join takes the common data. Yes. And Mubarak, your question is yes. It would only leave what is common between them. So as you can see, if you look at it, it's just 5 and 6, which is Gates Williams and Musk Elon. That's the only thing that would exist when you join them together. This is how an inner join works. While if you are dealing with an no, we'll take care of this in the coding section. Now, this is the concept of a left join. You would see that in the case of a left join, it keeps all the information from the left table. Remember, the left table is our person's table. So the left join keeps all the information from our left table, then includes the information for the right table. But in the case where it doesn't have any reference for that table, it will put null values, as you can see. I think the table here, if you look at the two tables and how it comes out, it gives you a very, very vivid description of what the tables are like. So basically, you see, everything in the left is kept. Only where information on the right is available, it is made available. The rest of it, null values. Then, in the case of a right join, you would see that what basically happens is that everything within the right table is kept, which is our grade and this. And then the information from the left that corresponds to the right is brought in, while every other thing is null, which is what happens in the right join. So then an outer join basically returns everything within the left and the right table. So the tables are basically joined together in such a way that where you do not have information that corresponds to both, you just have null values. So that's really it. I think these images basically describes what these joins do. If you look at the 4 images and look at the initial tables, look at the 4 images, you'll get a very, very good understanding of how each of these joins work. But the truth is, in most cases, inner joins and left joins are the ones you use mostly. So that's that for this slide. So we'll go to the coding section now. But before, as I prepare to go to that section, I would like you, if you have any question, please kindly ask. If you have any question, please ask. Raise your hand and just so that we can. Doesn't so no one has a question? So we are good. Okay, that's a good one. We understand what's happening. Now let's go over to this the coding section. Now basically these are just preambles that you should read up on. They help you to understand what's happening. But now let's get down to this part of the class where you remember during the slide we had these instances. I just skipped them so that you'd now what we're basically doing here, we are creating a data frame. You could call it a table, and you can see, remember when we were describing what a row is, we described it as either an instance or a tuple. And you can see in the creation of this data frame, you can see that each instance, which is, for example, ID1, which is Coulter Zico, is actually a tuple of one Coulter, a string of Coulter and Zico that was used to form that particular instance within the data frame. The same thing applies to the second instance, the third instance, fourth, fifth, and sixth instance. Then obviously in creating the data frame, we needed the title of the tables, which is what we fed into this function, this data frame function class rather. Now, it gives us a data frame that is structured like this. So what we now did next is, now remember in this case when we created this data frame, automatically an ID is created, an index is created that starts from 0. Remember, Python is 0 indexing. But we could decide to use any of our attributes or variables as the index, which is what was done here. df.set index as ID. So we use the ID column as our index. But there's something you'll notice here. Now, doing this, if you do it this way, one thing that will happen is when you go back and start working, if you try to reference the ID as the index, it wouldn't work. Because in this particular instance, it shows you what it can do, but it hasn't really been done on the data frame. Because remember, let me show you something. Now, if you look at df.set index keys drop true, append false, you see that in place is equal to false. By default, in place is false. So what if you wanted it to be applied to the data frame such that subsequently as you use the data frame, that this particular command that you've run will be applied to the data frame, you need to change this parameter in place to true, which is what we did here. You'll see that before, because we have not done that, if you come back here, you see that the ID is not the index. So to correct that, you have to set the index and do the in place equals to true. And when you check the data frame, you see that the ID is now the index. I hope we are all following. Does anyone have a question about the setting index? Please ask if you do. Now,
So, sorry.
okay.
The headings, how did you put the headings? The first name is not the last name and the first name.
Oh, this is where we created the data frame, right?
Okay,
As
I
you
can
can
see it.
see, the column headings by is just arranged that way. So, who else has a question? Questions are highly welcome to make this interactive. Then let's go back to now. There are two particular instances where we two particular functions that we use to, or methods that we use to work with data frames in pandas. One is, we call it lock, loc, then there's iloc. Now the difference between them is we use them to describe uh, rows and column more or less. So in this instance, the lock basically says, now this is what we are working with. Our ID is our index, basically our rows, and then we have two columns which are last name and first name. So df.lock1, remember what one is. One means the first index. Remember, I know that Python is zero indexing, but in this particular case, when you are dealing with lock, you specify the particular index you want to work with, not the location. If this was iloc, if you did one, what it will go to is the first one, which is index 0. But remember, since we are using ID as our index, which starts from 1, you have to specify the particular index that you wanted to get. So basically what is happening here is that lock, then you provide the row and what column you want to get a value for. So you are saying for this data frame, the row with index 1, show me the value for the column last name. So if you look at it, this is where you have index 1. Then for last name, the value is Coulter. Now for this instance, what you are saying is show me all rows. That's why you have this column. You are saying show me all rows of the column last name, which is what we have here. But you know that in dealing with Python, pandas, there's a data frame, there's what we call a data frame and what we call a Python, a series. Now, what usually happens is this. Every column within a data frame is a Python series. That's why you have this unstructured, this particular command gives you, returns a series object. While if you put the last name, the column in square brackets, it returns a pandas data frame that gives you the ID and the last name. So that's basically, so you say all rows for this particular column. So if you want it in form of a series, remember there are things you can do with a series. There are functions that work with series, that work for data frame that don't work on series, and vice versa. So depending on how you want to work on it, you can do it either way. Now, in this particular instance, we are doing some slice. We are saying, give us lock 1 and 2, all columns. So you are saying give us the rows with ID index 1 and 2, and show us all the columns, which is what this has given you. Now we can also use this such that we can change the value within a row within a row using lock also. You see, so for this instance, we are saying, remember, when you go to our initial table, the value of index one of ID one last name is Coulter. Now to change it, we just have to go down here. It says give that same command and say equal to. In this case, we change it to Coulter. So that value will be changed within the table, within the data frame. We can also create an entirely new instance. In this case, we are saying create a value with ID index 7, and the value for both columns should be More and Andrew. So if you look at the data frame now, we will now have, initially we only had up to ID 6. Now we've created a new instance which has an ID of 7, a last name of More, and a first name of Andrew. But like I said initially, if we wanted to work with just, for example, you wanted to work with the, let's do something. The first you see now, the fourth, we're asking for the fourth value. Now, the fourth value means that it is likely to be the one with index 3. Oh, sorry. Oh, sorry. Remember we have 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So if you run this, you get Bill instead of Shovik, because you are saying give me the fourth index, but in this case it will be the fifth because you have 0, 1, 2, 3, 4. So it identifies the fourth one, the fifth one instead of the fourth one, as the case may be, because at the end of the day we have 0. Python works with 0 indexing, but our ID has 1 to starts from 1. So while you have 1 here is because you have 0, 1, so it's the first name is asking for, which is Bill. So that's basically when dealing with iLock. Remember what I said, when you deal with lock, you specify the actual index, which is what we did here. When you say index 1, it will go to the table and look for 1. But in terms of iLock, it will go and look the index reference starting from 0. So that's the difference between lock and iLock. Okay, Jerry, please ask your question.
Okay. My question is for iLog. Is it not taking the ID column as an attribute too? Because we are doing one now and it's going to the last to the first name. So that means it's disregarding the first column, which is the ID column.
The ID column is an index.
So that means iLog also recognizes that that's an index, but it just doesn't
Yes.
work with it.
Yes.
Okay. Thank you.
It's still an index, but if you were to change it, it will be different. Something seems wrong here. Hold on, please. Oh, okay. Hold
I
on,
think it
please.
should be a comma. Okay.
I haven't run the. That's why. Okay, so wait. So you see that this is 5, 1 gives you Elon, which is the sixth value within the index. So that's basically it. It still recognizes the fact that this is an index. The ID is an index and works with it based on that. Now, the next part, Jerry, do you still have a question? Okay, fine. You put your hand there. Does anyone still have now? I want to confirm, please. I want everyone that is hearing me, please raise your hand. If you're hearing me, raise your hand because it looks like not everyone is engaged in this class. So that it won't look like okay, still waiting. We still have more people who have not raised up their hand.
Oh, it's locked. Sorry.
Still waiting. Who is Adedayo? Grace. So we have 1, 2, 3, 4. I think we still have like 5 people who have not raised their hands. Are they hearing me? Ogaga, Kehinde, Adedayo, Grace. You guys are not raising your, except obviously there's a possibility that maybe. All right, let's just go ahead. Now, you can put down your hand, but if you need an explanation or you have a question, please kindly let me know so that of what we've done so far. So far, is everyone saying that they understand everything we've gone through so far? If that's the case, what we've gone through so far, you understand it. Toyib, Ahmed, Odile, Josh, please, you can put down your hand now. Thank you. Except if you
Sorry,
have a
sir.
question. Okay,
Sorry,
go
sir.
ahead.
Okay. At the beginning of the code you just explained now, please can you go
Okay.
up?
Okay. Is it around these pandas or when we
Yes, up.
still up?
Yes. At the beginning, the beginning when you were putting up the
Okay,
table.
this is the first
Okay.
one.
So you're saying if you don't, we only use the pandas. The table can only be used by importing panda.
How do you mean?
At the beginning of the code, you said import panda as PD. Is this data from the panda library or I don't understand?
No. Basically what we're okay, hold on. Let me do something, please. Invalid. Hold on. Okay, I see what the problem is. Did I remove the comma? No. Invalid ID.
You're supposed to put a square bracket after that number 2 before the colon to close this square bracket.
Oh yeah, that's true. Messed up on that.
Mr. Ike?
Yeah, I can hear you. Thank you. Um, I think it was Mubarak that just asked the question, right?
Yes.
Now, as you can see now, I have shortened what we had initially. Basically, what's happening here is this.
Yeah.
Let me just. What's happening here is that we imported pandas. Now we want to create, because ordinarily when you are working, maybe you'll be supplied with a CSV file or an Excel file. In which case, what you would simply do is to get your data frame, you do something like import pandas, and then maybe you'd say df equals to pd.read.csv. Then you supply the name of the file, assuming it's in the same place where this notebook is, and then you can get your data frame. But in this case now, we don't have an Excel file or a text file that we are reading. We are trying to build out the data frame by supplying the data by ourselves. So what we are saying is that this was manually imputed.
Okay.
If you were to do this, you could easily cut this away and basically do an empty. You see now, this is an empty data frame with no data.
Okay.
So in which case you now have to fill it up. If you had an empty data frame, what you could now do is let's do a, what you would do now is this. If you had, for example, you see that we have an empty data frame. What we would want to do now is to say df id equal to, let's say, copy 1, 2, 3, 4, 5, 6. You can see, right?
Yes.
And so you see that by doing this now, we've imputed the information for ID. So now, if we wanted to put the other information, we could easily also just repeat this. We could repeat this by just simply, let's, guys, give me a few seconds. My battery is quite low and I need to put on my generator. So just hold on. All right. Mubarak, as I was saying, we could just repeat some of the things we've done here. Oh, let's redo that. This should be last name. As you can see, what I'm basically saying is that we created our data frame from scratch, basically. So what we did was a method that creates it at once. This method I'm showing you now is a way whereby you can create an empty data frame and then fill it up with the information as the case may be. But this, what we did initially, creates it at once, basically saying that each instance, if you really look at it, what it's saying is that for the first instance, supply this information. The second instance, supply 2 Z and Edgar. Third instance, supply 3 Lee, and then for the column labels, supply ID, last name, and first name. So basically, it just does it at once. So that's what we're working with here. Mubarak, do you now understand?
Yes, yes, I do. Thank you.
All right. All right. Who else has a question before we go to the next section? Omobolaji, if you have a question, just unmute yourself and ask your question. What about Raji? Aisha, do you have a question?
Yes. Please, you mentioned something about series the other time. So I'm
Yes.
sort of confused. I want to know the difference between a data frame and a series.
Well, just look at it this way. This is a data frame. You can see my screen, right?
Yes.
A data frame contains um, multiple columns and rows. A
Okay.
series is just one column. Now,
Okay.
but you would notice that when I did what I did initially, you see that this is one column and this is also one column. But in this instance, we structured it in such a way that with just one column, you can also make a data frame with just one column. But ideally,
Yeah.
every data frame is made up of several individual series, because like this last name is a series, first name is a series. Together within pandas, they are a data frame. But
Okay.
obviously, you could most of the functions that work on the series function on the data frame also. They work hand in hand. But for it to look better, and I think there are particular instances whereby certain functions don't work with series but maybe work with the data frame and vice versa. So it depends. But just
Okay.
understand that the understanding is that the series is just one attribute within a data frame. If you
Okay.
work with it that way, you'll be fine.
All right. Thank you.
So Omobolaji, do you have a question or you forgot to bring down your hand? I'm guessing it's the latter, not the former, because your hand is still up. So let's go ahead and deal with SQLite. Now, SQLite is basically it's a database. It's inbuilt. It comes inbuilt in Python. It comes inbuilt in Python. You don't need to install it. Every other database, if you want to use them, you might need to install it. But SQLite is inbuilt, especially if you, for example, if you write their Python packages like Django. The database it comes with when you're writing, when you want to build an app with Django, it comes in built with SQLite, or you can then change it and do other things. But it's a very lightweight database. That it is lightweight doesn't mean that it's not. It does a very good amount of job. But in most cases, in actual production, the people are less likely to use SQLite. But within this course, we're going to be working with SQLite and how you can connect to a database using Python. So that's basically what we are trying to look at. And it's not, when I say connect to database, it doesn't mean that it's only SQLite databases that you can connect with using Python. For example, in my office, my team lead, I don't do that much, but my team lead connects to our uh, Microsoft Microsoft's SQL server using Python. It's not so different from what we are going to do here. There's just a little bit of nuance with respect to connectivity because of the fact that and security, because an SQLite database might not have security depending on when you are using it. But it's just basically so now what you do is you import SQLite 3, you create a connection. So SQLite 3 dot connect. Now, database.db is the name of the DB. If you downloaded the if you downloaded the CSV, wow, hold on, please. Now, if you downloaded the Jupyter, the zip folder from the notebook within the course for this class, you should have the database within it. It comes, it's there, it was provided. So you create a connection and then you create a cursor that you would work with. Now, as you can see, when you are done, you just the connection, close the connection using con, which is the connection you created, don't close. So import SQLite, so we connect to the database. Now, what you'll be seeing within this stuff in red, you see this is a string. What is within here is an SQL command. So the only part that is Python is cursor.execute, cursor.execute, and con.commit. Those are the only parts that are part of this, the Python part of it. Every other thing you're saying is SQL. Now, what you're doing here now, you are saying create table. This person. So you are saying create the table called person. Now you are not saying what will the table have. You are saying it's going to have an ID column. The ID column will take integers and it will be the primary key. You're also saying create a last name column. The information within that column will be text values. You're also saying create a first name column, and also the information within it will be text values. That's what basically this command says. Say create table. You could say create table called person. So you are saying create a table called person with 3 columns: ID, last name, and first name. But you specify first the data type, in which case you have integer, text, and text. Then you also have to specify what your primary key will be. What you also do in this second part is to create the second table called the grade table with 3 columns: a person's ID, a homework 1 grade, and a homework 2 grade. Each of them will have the data type they'll be using is integer, and the person ID will be the primary key. So after you've executed, you can now commit. Now, the reason I'm having this issue is because I have already created these tables. So these tables already exist. That's why if I wanted to do this again, I would have to go and delete. Hold on. I would have to go and delete this the database.db. If I delete the database.db, then I'll be able to run it again. Let me see if I can just do that. Just hold on. Because of my connection, I can't even delete it. So basically, what I'm okay. Let me just do this. Let me close. Now that I've closed the database, I can now delete it. Oh, I still can't delete it for whatever reason. Anyway, what I'm trying to say is this: I have already opened this database, and this creates what we need, the tables. Forget about this. Then what you're doing here now is to start inserting value. Remember when we created the pandas data frame earlier on, we provided the value within the table. So here you're saying cursor.execute. Now what is within this is an SQL query. So you're saying insert into the person's table, and you're asking Values basically tells you what instance, one instance. So you specify an instance. Then you do it for each instance that you want to put in. We do the same thing for the grades table. We provide the instances. Then based on that, we can now run. So I seem to be getting so many errors. This isn't even funny. Table already exists. Wow. Guys, please just hold. Give me a minute. Let me see some of you have comments. Yes. Okay. King James, you had a question. Have you had has somebody answered your question, or has it been clarified? Has it been clarified? King James, if your question has not been clarified, please kindly let me know. Because you're asking to create a data frame, we need to import our data and columns. Yes and no. In this particular instance, yes. In some instance, you you have to import your data from maybe a CSV file or any other file, even from a database. So let's guys, please hold on. I'm trying to sort something out. There seems to be an issue. I want us to really look at this stuff. So let me quickly sort it out. Okay, so I'm back. Let's run that. I was asking, King James, has your questions been answered? Are you sorted so that we can go ahead? If your question has not been answered, I can get back to it. Although we have like 30 minutes left. So I just created a new the database all over again so that we can see. So once we run this command, it creates the database. Then when we run this command, like I said, this creates the person table and this creates the grade table, and we run it. Then in this particular case, we are putting data into the tables. We are inserting individual instances using this SQL query. Then we run it. Okay, someone have their hand raised up. Okay, King James' question has been answered. Jerry, please ask your question.
Yeah, that's so you the SQL part will always be in the
I
top.
didn't get that.
The SQL part of the code. Are you seeing
Yes.
it will always be in the inside the three quotes, these three quotes that I did that normally
You
quote
you can
for a
either you
text
can either yes, it has to be inside there. But I think even if you use
time no
the
differentiate between this one and when you are saying this item should not be run like like ash.
but you are remember you're running this within a function
Oh,
execute.
okay. Within okay.
It's within the
Uh,
execute function, so you understand what's happening there.
oh, okay.
All right. So we've been able to create a database, create tables, input information into the tables. Now we want to see the information within the table. So we run this. So we are saying for every row within the person table, print the row, which is what just happens here.
Hello, sir.
Then, yes, go ahead.
Yes, you created a database.
Yes,
Let's say there's a database given by a company and you want to connect it to the database.
yes.
How do you do that?
That's what we are doing now.
Okay, but you said you created this database yourself.
This particular one, we created it.
Okay,
Now, we've created the database now. Now, what you if you wanted to connect to an existing database, you will still go through this process. If it's an SQLite database, you import SQLite 3, you create a connection. Now, what happens here is this. If this database already exists, it will connect to the database.db. But if this database does not exist, it will create it. That's what this command does.
oh, okay.
So the reason is this: if you have it, it will connect to it. If it doesn't exist, it will create it. Like I said, the company you work with may be using for example, a Microsoft SQL server or a Postgres server. It's not difficult to do. All you need to do is how to connect with. But if you wanted to connect to those ones, you won't use SQLite. There's a there's a there's a package called, I think it's Pi. Okay, CyclePy. There's actually something you could use. There are packages on in Python that you can use. You won't use SQLite 3 to connect, but you can just Google it how you
All
can
right, sir.
connect to
All right.
it's you will see ways of doing it. It's not quite difficult. You just need to calm down and understand what's happening. So, but here now, what we are doing now is, yes, you are connected to, what this does to you for you is connect you to the database. Now, if you want to now pull information from the database, you will now use the cursor to execute a command. In this case, we are saying get us all the values within the person's table, all instances. Now we are iterating through all the instances and printing them one by one, which is what we did here. For role in cursor.execute, what cursor.execute does is it pulls all the information within this database and pulls it and holds it. Now you can now iterate through it and then print out the value. That's what's happening here. Now, but Also in pandas, there's a way by which you can run that command and immediately send it straight to a database, to a data frame, which is what we've done here. We run the pd.read SQL query. So it reads this query. We use the connection we created initially. So what basically happens is that we run this command within the database. Remember, this connection connects us to the database. So this query is run. Now you are now saying, okay, for the what column do you want to use as an index for the new data frame you are trying to build? So you use the ID, which is what you specified here. So you see that we now have a data frame here. That's basically what has happened here. So you can even put it as a variable. You can say df and then you can make use of it. Now, what we have here is basically trying to explain to you putting conditions, running because select column from tables where conditions. This is just basic SQL query. So select the ID column from the person's table where, so you give a condition, which is what we've done here. So we are saying select ID and the last name from the person's table where the ID is greater than 2 and create a data frame with it where the index, the ID column is the index. So you see that for the 1, 2, it's not included because we've given in a condition whereby the ID is greater than 2. So this is basic SQL command. Now, to delete values from the database, you run an SQL command. No, sorry. This is to insert. Insert means, remember what we did earlier on when we created that data frame and we used the lock df.lock to create a new instance with index 7. So we are doing the same thing here using SQL. So we are saying insert into the person's table and we provide the instance with the values command. The index will be 7, the last name will be More, and the first name will be Andrew. Then we say to it, we now, after executing it, we now put it within, we now run our query to see everything within our database. You see that we now have the 7th, the value, the instance with index ID 7 that we've created. We can also delete from the database using delete from person's table where ID is equal to 7. So it deletes that instance. So if you run this now, you can see that the database no longer has that instance. I hope we are following what I'm doing and we understand what I've been able to do. If you're new to the SQL command, it might look a bit, if you have questions surrounding that, I can answer as much as possible. Just ask the question so that we can answer you.
Sir, can we also replace the way we did for the panda? Hello, sir.
I can hear you.
I said, can we also replace? There was a part we replaced the last name and the first name when we're dealing at the beginning when we're dealing with the panda.
Yes. See, let's get something straight. SQL, pandas, all these things are tools. They are tools. There's a command for replacing value within SQL. All you have to do is find such a command. There's a command for replacing values. So, for example, all you have to find is the particular command. For example, insert or delete. There are so many of these commands. Depending on what you want to do, you can just Google it. You can replace values within a table, and as the case may be, or you could decide to delete the instance and now write a new. Another way you could do it is, let's say you wanted to replace a value, even if you don't know the command, you could delete that instance and then delete the instance and then rewrite it with the new information you want to do. So that's a way of doing it. But
All right.
specifically replacing, there's a way of replacing it. I can't come up with the command in my head right now, but there's a way of doing that.
All right, sir. Thank you.
Yeah, there are functions for all these things. Now, back we now go to the join. Now you can see that what has been done here is uh, you can see that this is these two. What basically we did was to pull everything from we created a data frame from the person's table within the database, which is df person, and we created another data frame df grades, and we joined. I don't like the way they did this. Hold on, so that you can really understand what's happening here. Cut. I like to break them down this way so that you know what's happening. Just hold on. Okay. So now, as you can see, we have pulled what was inside that person's table into a data frame called df person, which is the same thing. So df grades. We've done the same thing. We've pulled this in. So we now have two data frames, df person and df grades. Now we want to join them within pandas in Python. Our join is done with a function called merge. So what we are doing now is we are doing an inner. We are saying take the df person's table, which is this one, and join it to the df grades table, which is why we, after the merge function, df person dot merge, the first value you give is df grade, which is the second table. Then what kind of merge do you want to perform? An inner join. How? Inner. Now you are now being asked, what are the two columns that you want to use to join them? On the left, which is our df person, the column we are working with is the id column, which is why we specified it here. On the df grade, we are working with the person's id, which is why we specified it here. So when you run this now, you see that, remember how we said our inner join is an intersection between the two tables. So you see that it's only in 1 and 2. Sorry, we have 5 and 6 rather, that we have in both tables, which is why this table is like this. Now to do the same thing, now what we have basically done is, let's do this same thing. Let's do okay, this is still an inner join. Hold on, trying to. Oh, okay. Now, what has been done here was they basically made the IDs and person ID to be the index. So instead of specifying what you want to join by making them the IDs, the columns you want to join by making them the indexes, instead of specifying them, you just say left index true, right index true. So you are saying join by the index. You have specified true for both. So it will use these values to achieve the same thing we did earlier on. So now this is using pandas. We've done it with pandas. Now let's do it with SQL. So what we are basically doing in this case now is that we are creating a data frame by running a command in SQL whereby we join the two tables together. So we said select all from the persons table and the grades table, where persons.id is equal to grades.id. As you can see, it creates that same inner join, but this time we used an SQL query to achieve it. Then in this case, now what we are doing is we are creating a left join using pandas. So in this case, our how is basically left. So df person.merge, df grades, how, all that changes is the how. So initially we used inner, in this case we are using the left because we want to do a left join. And as you can see, the results are similar to what we did on the slide. Now we are trying to do this with SQL. So in SQL, we basically write the same command, but if you see initially, what we did here was to say, we just used where. We didn't even have to join it. Where these two align, give us the tables. But in this case, you have to specify that you are doing a left join. So you say select all from the persons. Now, you remember the way the left join works is such that every information within the first table on the left is provided. Then only the information within the right table that is available will be provided in the joined table. So what we are saying is give us everything within the persons table, left join it with the grades table on persons ID and grades.person ID. So it basically does the left join and puts non-value for where there's no intersection, there's no connection between them. So you get a null values. The same thing applies to a right join. In this case, remember everything for the right table will be returned. Everything for the right table will be returned. While in the instances of the right table that is not available in the left, non-value will be provided. But the part of the left table that has no connection whatsoever with the right will be thrown away. So all that changes is the how. That's when doing it on pandas. Then there's the part also doing it on pandas, the outer join. All that happens is change the how to outer. So basically, to run every join statement in Python using the merge function, all that we need to change, that will change depending on what kind of join you want to achieve, is the how value. If you want to do a left join, the how will be equals to left. If you want to do a right join, it will be right. If you want to do an inner join, it will be inner. If you want to do an outer join, it will be outer. So that's just it. It's just basically the same command, but changing the variables to suit what you're trying to do. So far, that's the end of what we have to